Hi everyone, how's it going? So today I'm trying something new where I'm basically going to be reading some articles and reacting to it. In my personal life, I end up reading actually quite a bit. So I thought it might be a good use of time to read and also kind of react to like things that interest me. And hopefully these things that I react to, you guys would also find interesting. Today we're going to be reading an article about building AI agents. So let's get right into it. This is a Medium article. I believe it's a paid article, like a members only article. So if you don't have it, then lucky you. You get to read, you get to see this article that's usually behind closed doors. So let's get started. Building AI Agents, Lessons Learned Over the Past Years by Patrick Dougherty. So when I ran into this article, I was just like pretty interested in it, mainly because it has to do with AI agents. I've been thinking a lot about building agents, maybe using, there's a ton of different frameworks like AutoGen, Crewai, Swarm. There's just like a lot of different ones. I just haven't really had a good use case. I was thinking about maybe building something to automate some of my YouTube processes, but I don't know. So, but yeah, this is why I decided to read this article. So let's get started. Excitement, the first time we had a working prototype internally. Anticipation when we launched it in prod for customers. Frustration when it initially struggled to generalize to all real-world scenarios. And finally, pride as we achieved some baseline of stability and performance across disparate data sources and businesses. Building AI agents over the past year has been a roller coaster, and we're undoubtedly still early in this new wave of tech. Here's a little overview of what I've learned so far. Okay, this has so far been very hard to read. I don't know why, but all right. It's like a interesting little picture, probably created by ChatGPT. It looks like. Here's a depiction of the future where AI handles all knowledge work, allowing you to enjoy quality time with your family in technology, advanced and harmonious environment. With these AI pictures, I always find it's pretty poorly generated. But when it's zoomed out like this, it's like totally fine. So let's keep reading. Definition. First, I should define what I'm talking about. To borrow the words of this user in Twitter, what the hell is an AI agent? I try to put my own as conscious as possible definition on it. Patrick Dougherty says, my definition of an AI agent is 1. Takes directions, that is, human-provided objectives. 2. Has multiple tools it can use, that is, call APIs, retrieve context, etc. And 3. Autonomous reasoning to decide how and when to use its tools to accomplish directions. All 3 components must be present. So I kind of agree here. I think at a high level, agents take directions, has multiple tools, and tools can be just like anything, right? Any behavior that a computer can do, essentially. And operator, if you guys don't know about it, like ChatGPT recently announced. I guess they released it to the pro users, but it kind of does this, right? You give it a direction, it goes out using some of its like tools, and then autonomously makes some decisions. I think operator is not 100% autonomous, where it gives you like actions, like the operator will reach out to you and like say, hey, are you sure you want to do this, and things like that. But yeah, at a high level, I agree with Patrick Dougherty here on what an AI agent is. This definition is generally aligned with what OpenAI calls GPTs in ChatGPT and assistants in their API. However, you can build an agent with any model that is capable of reasoning and making tool calls, including Claude from Anthropic, Command R from Cohere, and many more. I've never heard of Command R plus, but yeah, I might take a look at it. Note, tool calls are a way for a model to express that it wants to take a specific action and get a response back, like get weather forecast info from Seattle or Wikipedia look up delivery pizza. Sure, yeah, that's reasonable. To build an agent, all you need is a few lines of code that can handle starting a conversation with some objective and an agent system prompt, calling a model for completion, handling any tool calls that the model wants to make, doing this in a loop, and stopping when it's done with this work. Here's a visual to help explain the flow. Hopefully my dark mode reader doesn't completely wash this out, but yeah, so here there's a person, a user, directions. It looks like it's calling with directions available to the tools, execute the tools, get results from the tool. Yeah, it's a pretty simplified like explanation of what he's been talking about. So let's take a look at this next part. You know, the thing about Medium and these kind of things is I hate reading these little text boxes. It's always hard to. You're a Rasco, an AI assistant, and redacted with the production access to user databases. Your knowledge is both wide and deep. You are helping redacted team members analyze their data in redacted. Your process, you're an expert. You help the users understand and analyze their data correctly, be proactive, and participate and anticipate what they need. Don't give up after your first failure. Reason and problem solve for them. Think carefully about how you will help the user accomplish their goals. Execute your plan anonymously. If you need to change your plan, explain why, and share the new plan with the users. Your rules. If you're not sure which column, table, SQL to use, ask for clarification. Assess if the available data can be used to answer the user's questions. If not, stop and explain why the user redacted. I don't know why he put all these redacted things. It's not that helpful for the actual article. But yeah, like these kind of prompts is pretty common in AI agents creations. I always find these kind of like very interesting. They're like, you know, the thing about prompting is that it's very difficult to get it right. Because it's not like a program, right? There's no like static checking or anything. It's just a prompt, and prompt evaluations and like adjusting prompts versioning it's like a whole thing that I've been thinking a lot about. And I know there's like open source things like PromptFu and other kind of evaluation systems, but honestly I feel like it's going to be a huge part of like development, like managing your prompts in the future. So anyways, let's continue on. It's also valuable to highlight what an agent is not. An agent is not scripted. Agents by definition do not follow a predetermined sequence of steps or tools calls, because the agent is responsible for choosing the right tool call to make next. Which, yeah, I don't know if I agree with this 100%, because some stuff, like I would argue a tool is a scripted part of an agent's response, personally. Anyways, artificial general intelligence, AGI. Agents are not AGI, and an AGI won't need agents for specific types of work because it will be a single entity with all possible inputs, outputs, and tools at its disposal. And my 2 cents is that none of the current tech is even close to this. Yeah, I guess so. I kind of agree about current tech not being close to what AGI should be, but AGI is like a pretty loaded term, right? Like people have different definitions of AGI. But yeah, like I think OpenAI was like touting that they achieved AGI and they're moving to ASI. But I don't know. I like, to me, I feel like AGI, we'll know when AGI is here. Like there will be no doubt. Okay. Black box. Agents can and should show their work in the same way that a human would if it was delegated a task to them. I mean, yeah, I don't really understand this point. I don't know why it's such an important point I don't think it matters. All right. Here's some context. My lessons learned in the first year of working on AI agents comes from firsthand experience working with our engineers and UX designers as we iterated on our overall product experiences. Our objective, a platform for customers to use our standard data analysis agents and build custom agents for specific tasks and data structures relevant to their business. We provide connectors to databases, that is Snowflake, BigQuery, etc., with security built in it. The tool calls for RAG or RAG over a metadata layer describing the contents of the database, and tool calls for analyzing the data via SQL, Python, and DataViz. The feedback on what worked and what did not comes both from our own evaluations as well as from customers' feedback. Our users work for Fortune 500 companies and use our agents every day to analyze their internal data. So they're basically some big like SaaS company that does database stuff, and I guess this tool is mainly like a RAG. All right. What I've learned about agents. Number one, reasoning is more important than knowledge. This code has been echoed in my head over the last 12 months. I suspect that too much of the processing power of GPTs is going into using a model as a database instead of using the model as a reasoning engine. Sam Altman on the Lex Fridman podcast. I kind of agree on this. And the recent advances in like O1 and O3 reasoning models, and even DeepSeek, which distilled those O1 models. And I feel like reasoning and agentic thinking is like kind of the next big scaling factor. I've long thought that model like size isn't going to be like the only determinator. And I really think reasoning is like the next big thing. The only drawback of reasoning is that it takes longer for your query. And that's why like DeepSeek and these other kind of models, they kind of show the reasoning that's happening. But if you think about what like the raw time that it takes for these models to have a response, it takes a lot longer. And it kind of mimics what humans do, right? What humans think. Because humans like first take some time to think about what they're going to do before they actually do the thing and give you the results. So I agree with this statement. Moving on. Agents are the appropriate response to this. I would apply this logic when building an agent as focus less on what your agent knows and more on its ability to think. For example, let's consider writing SQL queries. SQL queries fail a lot. In my time as a data scientist, I'm sure I had a lot more queries fail than I ever did succeed. Tell me about it. I'm terrible with SQL. If a complicated SQL query on read data that you'll never use before works the first time you run it, your reaction should be, oh crap, something's probably wrong, rather than, oh wow, I nailed it. Even on a text to SQL benchmark, evaluating how well models translate a simple question into a query, it caps out at 80% accuracy. So if you know that your model's capacity for writing accurate SQL queries translates to a B- at best, how can you optimize for reasoning instead? Focus on giving the agent context and letting it think instead of hoping it gets the answer right in one try. We make sure to return any SQL errors along the way with all the context we can capture back to the agent when a query fails, which enables the agent to resolve the issue and get the code working a vast majority of the time. We also give our agent a number of tool calls to retrieve context on the data in the database, similar to how a human might study the information schema and profile the data for distributions and missing values before writing a new query. Number 2, the best way to improve performance is by iterating on the agent-computer interface, ACI. I actually haven't heard of this term before. This is the first time I'm hearing about it. But yeah, the term ACI is new. Okay, introduced in this research out of Princeton, but the focus of perfecting it has been a part of our day-to-day for the last year. The ACI refers to the exact syntax and structure of the agent's tool calls, including both the input that the agent generates and the output that our API sends back in response. These are the agent's only way to interface with the data it needs to make progress aligned with these directions. Because the underlying models, GPT-40, Cloud, Opus, etc., each exhibit behaviors differently, the ACI works best for one won't necessarily be right for another. This means that a great ACI requires a much art as science. It's more like designing a great user experience than it is writing source code, because it constantly evolves and small tweaks cascade like a fender bender turning into a 30-car pileup. I can't overstate how important the ACI is. We've iterated on ours hundreds of times and seen huge fluctuations in our agent's performance, with seemingly small tweaks to names, quantity, level of abstractions, input formats, and output responses of our tools. So I feel like these are the things that is very difficult with AI, because it's not a perfect system, and it's sometimes very not deterministic at all. Like, there are tools like LangChain and LangGraph and these other kind of frameworks that help you like format the responses and like JSON or things like that. But even then, my experience with prompting and trying to generate things has been always pretty difficult to get exactly right. And I feel like that is kind of the crux of a lot of AI usage. A lot of people will just like kind of see some demo, like Devin's a really good example, right? They'll see a demo and it's just amazing. It blows your mind. But at the same time, it's just, when you try to recreate something on your own, it just doesn't work sometimes. It's like very, very difficult to get it right and get it exactly the way you want it. Moving on. Here's a small, specific example to illustrate how critical and finicky your ACI can be. When testing our agent on GPT-4 Turbo, shortly after it was released, we noticed an issue where it would completely ignore the existence of specific columns that we're trying to tell it about in a tool call response. We were using a markdown format for this information that was taken directly from OpenAI docs at the time and had worked well with GPT-4 -32K on the same data. We tried a few adjustments to our markdown structure to help the agent recognize the columns that it was pretending did not exist, even though they were in the response to one of the tool calls it was making. None of the tweaks worked, so we had to start experimenting with entirely different formats for this information. And after an overhaul to start using JSON instead of Markdown, only for OpenAI models that is, everything was working great again. Ironically, the JSON structure response requires significantly more tokens because of all the syntax characters, but we found it necessary and actually critical to help the agents understand the response. So this is another really interesting point about working with prompting and these models, is that if you try to like force it to a specific format like JSON, the performance and the speed and as this article mentioned, the token quantity actually goes up quite a bit. And I remember at my work, we were like debugging why certain prompts were taking so long, and just by removing like certain key values from our JSON format that we wanted, and kind of the complex formatting, the performance of the queries went up dramatically, and also the token size of the output. So yeah, this is like pretty accurate to my experience. Iterating on your ACI may feel trivial, but it's actually one of the best ways to improve the user experience of your agents. Okay, number 3. Agents are limited by their models. The underlying models you use are the brain to your agent's body. If the models suck at making decisions, then all the good looks in the world aren't going to make your users happy. We saw this limitation firsthand when testing our agents simultaneously on GPT 3.5 Turbo and GPT 4-32K. On 3.5, we had a number of test cases that went something like this. 1. Users provided an objective. For example, analyze the correlation between Starbucks locations and home prices by zip code to understand if they are related. Number 2, agent would assume that a table existed in the database with the name it hallucinated, like home prices, and columns like zip codes and prices, instead of running a search to find the actual table. You know, this hallucination problem is such a common problem. I remember, I don't know, I just feel like hallucination is like a big deal. And That's why I really like Notebook LM, where you could kind of just inject your own context into it, and it does a really good job of not hallucinating. So if you want a video on Notebook LM, let me know in the comments below. Number 3, agents would write a SQL query to calculate average price by zip code that failed and get an error message indicating that the table did not exist. Number 4, agents would remember, oh yeah, I can search for actual tables, and would run a search for home prices by the zip code to find a real table it can use. Agents would rewrite its query to correct the columns from a real table, and it would work. Agents would continue on to the Starbucks location data and make the same mistake again. Running the agent on GPT-4 with the same directions was completely different. Instead of leaping into the wrong action immediately and wasting time getting it wrong, the agent would make a plan with the correct sequence of tool calls and then follow the plan. As you can imagine, on more complex tasks, the gap in performance between the two models grew even larger. As great as the speed of 3.5 was, our users vastly prefer the strong decision-making and analysis capability of GPT-4. And you know, a lot of the things, and personally, I feel like a lot of the things that holds back local model usage is the fact that it's really difficult to run very good like reasoning models on it. I think DeepSeek is like the best, but personally, I haven't been able to run the 671 billion model efficiently, even with like the quantized work from like Unsloth AI. But yeah, like it's just very difficult to run it locally. And also like the actual model size that you want is also pretty difficult. But yeah, one day we'll get there. One day the reasoning models will get distilled so much and it will run so quickly that you could run on a 4090 or like an M4. So no, one thing we learned from these tests is to pay very close attention to how our agents hallucinate or fail when it happens. In the AI agents are lazy. I assume human laziness is well represented in the training data for the underlying models and will not make tool calls that they don't think they need to. Similarly, when they do make a tool call, if they don't understand the argument instructions well, they will often take shortcuts or completely ignore required parameters. There's a lot of signals in these failure modes. The agents is telling you what it wants the ACI to be, and if your situation allows, the easiest way to solve this is to give in and change the ACI to work that way. Of course, there are going to be plenty of times when you have to fight against the agent's instincts via changes to the system prompt or your tool call instructions. But for those times when you can more simply just change the ACI, you'll make your life a lot easier. Number 4. Fine-tuning models to improve agent performance is a waste of time. Wow, this is like a very bold statement to make personally. Because like, I don't know, I really feel like fine-tuning is amazing. I fine-tuned like stable diffusion models on my face. I fine-tuned I fine-tuned like llamas before to like some text, and it just works way better as intended. So yeah, I'm kind of interested in why he thinks fine-tuning is a waste of time. So fine-tuning a model is a method to improve the model's performance on a specific application by showing it examples that it can learn from. Current fine-tuning methods are useful for teaching a model how to do a specific task in a specific way, but are not helpful for improving the reasoning ability of the model. In my experience, using a fine-tuned model to power an agent actually results in worse reasoning ability because the agent tends to cheat its direction, meaning it will assume that the examples was fine-tuned on always represent the right approach and sequence of the two calls instead of reasoning about the problem independently. So this is a really interesting statement, and I guess you could kind of equate it to human biases, right? I guess for a reasoning model, it's better to be just purely logical. So maybe I buy this, but I think I would have to like test it out to see if what he's saying is actually true. Note, fine-tuning can still be a very useful tool in your Swiss Army pocket knife. For instance, one approach that has worked well is using a fine-tuned model to handle specific tool calls that the agent makes. Imagine you have a model fine-tuned to write SQL queries on your specific data. Yeah, see, this is what I mean. Like, you want a fine-tuned model that knows your database inside out, or you want a fine-tuned model for your specific tool for this specific job. So like I still feel like fine-tuning is very important. Imagine you had a fine-tuned to write SQL queries on your specific data. In your database, your agent running on a strong reasoning model without fine-tuning can use a tool called to indicate that it wants to execute a SQL query. And you can pass that into a standalone task handled by your models that fine-tuned on SQL queries for your data. Okay, Point 5. If you're building a product, avoid using abstractions like LangChain and Llama Index. This is pretty interesting too, because these tools are so popular. I almost feel like granted, I haven't built too many AI agents myself, but you know, like these are open source projects that will continue to evolve and get better. So yeah, like this is a very bold statement. This article has been just filled with bold statements. You should fully own each call to a model, including what's going in and out. If you offload this to a third-party library, you're going to regret it when it comes time to do any of these with your agents. Onboard users, debug an issue, scale to more users, log what the agent is doing, upgrade to a new version, or understand why the agent did something. I don't know if I agree with this. I feel like these tools have like at the end of the day, these open source projects are just code. So like you can go in and like figure out what's going on too. So and I feel like all of these things that they're mentioned, like especially like LangChain and stuff, these are common problems that these open source projects are probably handling already. So I don't know if I agree with that. No. If you're in pure prototype mode and just trying to validate that it's possible for an agent to accomplish this task, by all means, pick your favorite abstraction and do it live. All right, point 6. Your agent is not your moat. Automating or augmenting human knowledge work with AI agents is a massive opportunity, but building a great agent is not enough. Productizing an agent for user requires a significant investment in a bunch of non-AI components that allow your agent to actually work. This is where you can create competitive differentiations. Security. AI agents should only run with the access and control of the user directing them. In practice, this means jumping through a hopscotch of OAuth integrations, single sign-on providers, cache refresh tokens, and more. Doing this well is absolutely a feature. Data connections. AI agents often need live data from sources systems to work. This means integrating with APIs and other connection protocols, frequently for both internal and third-party systems. These integrations need initial build out and TLC over time. User interfaces. Users will not trust an AI agent unless it can follow along and audit its work. Typically, the first few times a user interacts with an agent, decreasing sharply over time. It's best if each tool call that the agent makes has a dedicated interactive interface so that the users can follow along with the agent's work and even interact with it to help build confidence in its reasoning behavior. That is, browse the content of each element in a semantic search result. You know, honestly, I don't think this is going to be the case in the future. I think this is probably this particular project. I think it makes sense because it's a SaaS kind of company, and it's like they're targeting like developers and like kind of like these people that are actively working with like pipelines and stuff like that. But honestly, for mass consumption, like mass consumer consumption at the scale of Meta and like these things, I don't think people care. They just want to be able to hit a button and say, hey, like Siri or whatever, order me a pizza from this place. And then the agents will go out and do its thing, and then they'll send you a text message saying that your food's on its way. I think that's kind of the model and the abstractions level that most people will want to experience. But I guess for like SaaS companies where they kind of want to see and like debug each of these steps, it makes sense to have like a user interface where the journey of the pipeline is being like kind of shoved. Long-term memory. AI agents by default will only remember the current workflows up to the maximum amount of tokens. Long-term memory across workflows and sometimes across users requires committing information to memory and retrieving it via tool calls or injecting memories into prompts. I found that agents are not very good at deciding what to commit to memory and rely on human confirmation that the info should be saved. Depending on your use case, you may be able to get away with letting the agent decide when to save something to memory, a la ChatGPT. Yeah, so ChatGPT and other, like, I don't know if Claude has it, but like, yeah, there's memory features. It's basically a RAG, I believe, behind the scenes, but yeah, deciding what to store in long-term memory and all those things, I think they all go through like some reasoning model too. Evaluations. Building a framework to evaluate your AI agents is frustratingly manual task that it never fully completes. Agents are intentionally non-deterministics, meaning that based on the direction provided, they will look to come up with the best sequence of tool calls available to accomplish their task. Reasoning after each step like a baby learning to walk, eventually these sequences takes two forms: the overall success of the agent's workflow in accomplishing the task, and the independent accuracy of each tool call. That is, information retrieval for search, accuracy for code execution, and etc. The best and only way I found to quantify performance on the overall workflow is to create a set of objective completion pairs, where the objective is the initial direction provided to the agent, and the completion is a final tool call representing the completion of the objective. Capturing the intermediate tool calls and thoughts of the agent is helpful for understanding a failure or just a change in the tool call sequence. Honestly, I feel like prompt evaluation and like evaluation in general in the agentic world is like a huge business opportunity. I feel like there are some companies that are doing this, but like to me, this is like your integrated test, your end-to-end testing. AI applications is gonna have these prompt evaluations and these, like, I guess, agentic task evaluations, and it's gonna be some kind of automated test, like some kind of score, right? You might even use AI to evaluate your AI. But I really believe this is going to be a huge part of the AI development ecosystem in the future. Note, consider this list a formal request for startups. Products around each of these items, if done well, can power the agents of the futures. 7. Don't bet against models continuing to improve. While building your agent, you will constantly be tempted to over-adapt the primary model you're building it on and take away some of the reasoning expectations you have for your agents. Resist these temptations. Models will continue to improve, maybe not at the insane pace we are on right now, but definitely with higher velocity than the past technology waves. Customers will want agents that run on models of their preferred AI providers. I don't really agree with this point. I think customers don't care what model is being used. I truly believe that people don't give a crap. People just want their stuff to work and work well. Like people, I really believe that people are very promiscuous with the models of their preferred AI providers. And most importantly, users will expect to leverage the latest and greatest model within your agent. When GPT-40 was released, I had it running in production accounts within 15 minutes of it being available in OpenAI API. Being adaptable across model providers is a competitive advantage. Again, I actually think this doesn't matter. I think if you're I really think if what you're providing, the service you're providing, works really well already, people are not gonna like complain that it's not on the latest model. Like, in fact, it should be abstracted away so that the user just doesn't even know. Like, that's my stance on this. 8. Bonus lessons learned. In this article focused on more strategic and product-oriented lessons learned. I plan to go deeper on some code and info lessons learned in the future article. Here's a few teasers. Need vector similarity search? Start with pgvector in Postgres. Only go to a vector DB when you absolutely have to. Open source models don't reason well yet. DeepSeek reasons pretty well. So this, I don't know when this was written. I think 12 days. I forget when this was written, but DeepSeek, baby. The assistance API is weird. it abstracts multiple things that feels like they should have stayed independent. Flat file, RAG, conversational token limits, code interpreters, etc. Please, OpenAI, just make a code interpreter an optional tool we can turn on when running a completion. Don't optimize for cost too early. Streaming tokens is a great compromise for users when dealing with AI latency. Agents are magic. Once you take the VC-sponsored ski lift up to the peak of inflated expectations and shalom ski through of disillusionment, you're going to be amazed by the plateau of productivity. There you have it. I'll give it a few claps. I enjoyed it. But yeah, this article was written by Patrick Dougherty. He's a co-founder and CTO of Rasco, writing about agents, the AI agents, the modern data stack, and possibly some dad jokes. But yeah, that was a good article. While I don't agree with everything that Patrick was saying, he has some bold takes, I think. A lot of like kind of pragmatic takes too, I feel. Like at a high level, yeah, it makes sense to try to just don't reach out for things that you don't need, just start with what you want to do, iterate, work quickly, making sure that you're not just relying on the models itself. Like you need to build your own. Like the one thing about the moat is I thought was really interesting, and I totally agree. Like I have said this before, but I think user experience and the ecosystem that your AI system is built on top is going to be the moat. Like how many people are on that? How many people are on your products and your software and loving your features? That's going to be the moat. In the end, in like 5 to 10 years, no one's going to be really talking about AI anymore. It's going to be like the internet. No one like talks about the internet. I mean, I guess they do, but it's like abstracted away, right? People just want to build, people just want things to work, and that's it. But yeah. Anyways, I hope you guys enjoy this kind of format. This is new. I hope you guys enjoyed this video, and don't forget to link some articles that you want me to cover and react to below in the comments below. I'll see you guys next time.